Recording has started now. Okay. So once again, good morning, everyone. And today we'll specifically focus on power quality standards. We're starting a new series, this will be the first of 3 training sessions where we focus on power quality, and then in the next session we're going to look at voltage dips, disturbances, and then thirdly on how to do a power quality assessment and on what everything entails regarding that. So I just want to share my screen. All right, Danielle, can you please confirm that you can see it? Wogo, maybe you?
Okay. Not yet.
See a few thumbs up, so let's give it a few more seconds while we wait. You can see it.
Yeah, I can see your screen, hi.
Okay, thank you. So I think before I start, just the last thing, please, if you can, just keep the questions until the end of the session. So I think there will be more than enough time to cover most of your questions. And even if there's more time left, we may be able to do a short demonstration on the reports that Osprey PRO can provide you. All right, so yeah. Just to start off, the learning outcomes for today and some of the main outcomes that I hope that you will get in this session is firstly, why is power quality more than just quality of supply? Why is it important to manage power quality? What is the role of the NRS 048 as national power quality standard? Sorry, can I just please ask that everyone just mute their mics? Thank you very much. All right, what is the role of the NRS 048 as a national power quality standard? Discuss the concept of compatibility levels. Why is a Class A power quality device certified for IEC 61000-4-30 edition 3 so important? How are disturbances measured? And then lastly, an example of power quality management solutions. Okay, so what is power quality? The IEEE defines power quality as the concept of powering and grounding sensitive equipment in a manner that is suitable to the operation of that equipment. Simply, it means that if you have a piece of equipment that works fine, then we don't have a power quality problem. However, if we have equipment that is overheating, tripping out, or affected by the incoming power supply, then we do have a power quality problem. The IC defines power quality as a characteristics of the electricity at a given point on an electrical system evaluated against a set of reference technical parameters. Right, a customer's power quality. Sorry, I get some feedback. All right. A customer's power quality requirements are determined by establishing by how far the supply voltage may deviate from the specified reference condition without having a significant impact on the operation or lifespan of the connected equipment. Now, these requirements may differ for different equipment within customers' installation and may also differ from installation to installation. Therefore, the requirements are not easily defined. But the next question would then be, when is power quality or quality of supply good enough? And that is the level that will not affect the specified operation of electrical equipment. Now, equipment is defined or designed, to achieve nameplate ratings for a certain level of disturbance. And if the disturbances exceed the design specifications, then the claimed performance is no longer possible. Right, so that is when you when the power quality is generally good enough. So what is the reasons for managing power quality? Traditionally, or in old power systems, large AC generators at thermal power stations had a lot of inertia and generated perfect sinusoidal voltages. Most loads were linear, meaning that they draw sinusoidal load currents, such as lighting, heating, electrical motors, and transformers. And these loads were not that sensitive or really sensitive to transients and voltage disturbances on the network. So in an ideal world, the system faults and disturbances would firstly not occur. Changes in the system load would not affect the system frequency. Loads would draw in-phase sinusoidal current when supplied to the sinusoidal voltage, and loads can tolerate any deviation in supply voltage, amplitude, and frequency. Now, in the real world, or in the modern world, modern power systems that we have today, transmission and distribution networks that connect utility generators to customers are prone to environmental influence, design and equipment problems, which can result in short circuits on the network. These high currents give rise to disturbances in the supply voltage. We also have a system frequency that may vary, that's not stable at 50 Hertz. So in a modern power system, there's also new types of loads and sources which lead to modern phenomena. So these loads are generally, in the modern power system, nonlinear loads, which draw distorted currents. Example of these loads are variable speed drives, household electronics, and so on. And these loads are also more sensitive to disturbances from the network. Now, power quality or bad power quality will impact the life expectancy and maintenance requirements and breakdown behavior of equipment where it's connected. So who is then involved in power quality? Now there's two parties that's involved. It's the utility and the customer. Voltage quality is not always or cannot be 100% under the control of the supply utility. And that's because of external factors, environmental factors such as weather, vandalism, etc. Utilities provide voltages that are not perfectly sinusoidal or balanced between phases, but also users or customers draw nonlinear currents through non-zero impedances, which cause upstream voltage drop. Now, if the current that's being drawn by customers are repetitive pulsating currents, such as arc furnaces, it can lead to flicker. And if these currents flow through asymmetrical supply impedance, or the currents that's being drawn are unbalanced, it leads to voltage unbalance at the point of connection. So a few areas where electrical utilities can degrade the voltage quality, or factors that influence the voltage quality, can be poor maintenance, poor network operation, and then also poor planning. And as you can see with all the above, that power quality is more than just quality of supply. It's both quality of supply and quality of use that contribute to the voltage quality at the point of connection. So it's clear that power quality has become a key performance parameter of a power system to manage operational risk, as power quality can have a significant economic consequences. And therefore, a minimum power quality standard balances the financial and technical needs of a growing economy, and it also provides a compromise between the ideal supply and the cost of providing such a supply. So users have the right to a minimum standard in power quality, and the supplier has an obligation, regulatory and also business risk, to supply that minimum standard. So power quality can be considered as the activity of optimizing the level to which the power quality conforms to the requirements of a customer's installation, so that the equipment is not affected negatively, or at minimum the NRS 048. So what is the NRS 048 about? The NRS 048 is a document describing the minimum technical levels or compatibility levels, which we'll get to in the next slide or two, or benchmark for voltage quality, and is set as the license requirement to anyone making money from electricity. So the NRS 048 aims to ensure a voltage waveform of acceptable minimum quality at the point of supply to a customer. The parameters that are used to assess the voltage quality is shown on this page, and these power quality parameters define a type of deviation from the ideal constant sinusoidal balanced voltage waveform. So the types of the parameters are divided in three categories. So the quality of voltage waveform, the voltage disturbances, and then also reliability. The NRS 048 Part 2, 2015 being the latest version, defines the compatibilities for the parameters in the quality of voltage waveform, and then the disturbance, and the NRS 048 Part 6 and 8 defines that for reliability, the reliability section. So just to give you some overview of each one of these parameters is, firstly, voltage magnitude is the deviation of the RMS magnitude of the voltage waveform from the declared voltage. Voltage unbalance is the level of asymmetry between the three phases of the supply voltage and the degree by which the relative magnitude differ and the phase displacement differs from 120 degrees. Voltage harmonics is the distortion in the sinusoidal waveform. Voltage flicker is the degree by which the RMS voltage magnitude fluctuates in time and how it impacts the perceived fluctuations in the intensity of incandescent lights. Power system frequency is the degree by which the frequency of the fundamental system voltage differs from 50 Hz. Voltage dips is a sudden reduction in the RMS of the voltage waveform below a given threshold, and then recovering to above that threshold within a short interval of time. Voltage swell is just the opposite of that, so it's a sudden increase in the RMS and then recovering below that threshold within a short interval of time. Voltage transient is a sudden increase in instantaneous magnitude of the voltage waveform above its fundamental peak value. And then interruptions is an interruption in the supply lasting longer than a defined duration. And then, lastly, the Saidi and Saifi metrics, which quantify the availability and impact of disturbances or outages to customers, or quantify the impact of disturbances and outages to customers. Right, so each one of these parameters, there's a compatibility level that's specified in NRS 048. The compatibility levels and limits provide measures of acceptable voltage quality at the point of supply to end customers, and is also the level of disturbance for which, with a suitable margin, equipment operating in the relevant environment is required to have immunity. So the compatibility level is a level that's set that, well, basically 95% of time will not exceed that level and is far below the immunity test level of the equipment. Okay, now just a few considerations from the NRS 048, and this is quoted directly from the NRS Part 2. So the compatibility levels and limits specified in Part 2 of the NRS apply only at the point of supply to customers. A licensee is not required to comply with these levels at limits at other bus bars in its network. Licensees are responsible for managing the networks and for negotiating customers' contracts, include measures to control customers' emission levels, so as to comply with the compatibility levels. And then for some parameters, disturbances levels could rise where present disturbance levels are below the compatibility level at the supply point. A licensee is not required to ensure that these do not increase, but is required to ensure that these do not increase beyond the appropriate compatibility levels. So both the NRS 097, so the small scale embedded generation standard, as well as South African grid code for renewable power plants call for the NRS 048 as a normative reference. But it's important to know that the interface does not only just apply to licensees in the license generator sense of word, but also to any customer that has entered into an electricity supply agreement with a licensee. Okay, now what is a power quality assessment? Power quality assessment refers to the method of interpretation of the aggregated measured values of each of these parameters with the purpose to compare these values to the compatibility levels specified in the NRS 048. So simply means that an assessment value that's used for all of these parameters, with an exception for short-term harmonics, is the 95th percentile of the 10-minute interval values. So that's how assessment is done for all of the above parameters that's described in the NRS 048. But what is the role of the IEC 61000-4-30? So power quality measurement standards on instruments are required to ensure that different measurement instruments provide comparable measurement results on the same signal. The accurate comparison and investigation of power quality results are challenging due to the large number of power quality instrument manufacturers, and therefore a standard on methods and interpretation of power quality results was required. And that's where the IEC 61000-4-30 comes in. It's an international standard on measurement. And it basically defines what must be recorded, so the parameters that must be recorded, as well as the precision of each of these. So for voltage dips, unbalance, THD, distortion, etc. In other words, it specifies how different measurement devices will report on power quality parameters. Okay, it provides a performance specification regarding the measurement equipment rather than design specifications. So that means that if two different power quality devices from two different manufacturers comply to the IEC 61000-4-30 standard, then there's no difference in the measurement data or measured data, because both devices are certified to the IEC 61000-4-30 standard and comply with the measurement rules and definitions. But there is, however, different classes. There's a class A, and then there's a class S. Now, again, quoting from the standard, a class A can be defined as this is used where precise measurements are necessary, for example, for contractual applications that may require disputes, verifying compliance with standards, etc. Any measurements of a parameter carried out with two different instruments complying with the requirement of the class A, when measuring the same signals, will produce matching results within the specified uncertainty for that parameter. Now, a class S is used for statistical applications such as surveys or power quality assessments, possibly with a limited subset of parameters. So basically it comes down to the class S performance methods do not provide the required precision as what can be found from a class A measurement instrument. Now, we've covered the NRS 048, and we know the NRS, you'll see if you look at the parameters, is a voltage quality or a quality of supply standard. But it's important to know that current also plays a key role in determining the quality of supply because of the quality of use that plays an impact on that. And the current can be used to understand the cause and the effect that it has on the quality of supply. So the NRS 048 calls for the IEC 61000-4-30 as a normative reference, but measuring both voltage and current is needed to do proper power quality management. And that is where the IEC 61000-4-30 edition 3 comes in and what that promotes. So the edition 3 is important because then the device is certified for both voltage and current. And just as a side note, the VECTO 3 that is manufactured by CT Lab is edition 3 certified. So always check that if you want to use a power quality device for your measurements. Okay, so what is the data or basic data aggregation that's required from the standard? Basically, it uses, or for all the parameters, it starts up with 2 milli or 10 cycles of 10 fundamental cycles, plus minus 200 milliseconds. So it's not exactly 200 milliseconds because the system frequency is not always 50 hertz. So the instrument counts the number of fundamental cycles by counting the 0 crosses. And then the 10 cycle values are aggregated over different time intervals. Firstly, it's aggregated to 3-second interval. Then, because power system phenomena normally changes slowly, it's aggregated to a 10-minute value, and it's that 10-minute value or the 95th percentile 10-minute value in the period that you use for NRS or power quality assessment. And it's then also aggregated to a 2-hour value. Now it's important, or the 10-minute interval value needs to be synchronized with the clock. And the IEC 61000-4-30 specify a 20 milliseconds uncertainty. The VECTO 3 GPS synchronized at 100 nanoseconds. So it's even more accurate than what the minimum standard is in terms of GPS synchronization. All right, so how does the measurement work in the VECTO 3? Well, how is it done? So you have your, sorry, voice there. Yeah, you have your voltage and current that you're recording from a VT or CT, or on LV you can measure directly. It's sampled at 500 kilohertz, which are then firstly down sampled as 50 kilohertz waveforms, instantaneous waveforms, or then the 200 millisecond or 10 cycle block data. The 50 kilohertz waveform data is then used to, or the IEC specify that it needs to permanently monitor half cycle RMS values to determine if there's a voltage dip or disturbance, where the VECTO 3 uses 6 cycle RMS values. The 200 millisecond block data is aggregated to 3 seconds and then up to 10 minutes and 2 hours. But just note that the VECTO 3 can also provide 1 minute or 2 minute variable minute data, so you can specify what interval of data that you require, but the NRS 048 uses the 10-minute aggregated values. And all of that values are, or intervals or trends are GPS time-stamped. Okay, so as I said earlier, all the parameters in the quality of the waveform part uses the 10-minute values, wherein for dips and swells and transients, the device permanently monitors the half cycle, or in case of the VECTO 3, the 6 cycle RMS data. Okay, some important considerations with regards to the measurement standard, and that is flagging. So flagging is important to avoid counting a single power quality event more than once in different measurement parameters. Flagging only occurs for voltage dips, swells, and interruptions during the measurement of power frequency, flicker, voltage unbalance, voltage harmonics, and voltage interharmonics. If during a certain time interval a value is flagged, then the aggregated value, which includes the flagged value, must also be flagged. So the 10-minute aggregated value or 3-second value needs to be flagged as well. And that flagged data must then be removed from the measurement data for your power quality assessment or for the purpose of power quality assessment. But note that the exclusion of flag data is only applicable provided that it's less than 10% of the data have been flagged. So in the period that you are measuring or using for power quality assessment, not more than 10% can be flagged in order to exclude the flag data from the power quality assessment. All right, now getting back to disturbances, specifically looking at voltage dips, swells, and transients. How is voltage disturbance or event triggered? So I've covered this briefly. The detection of a dip or swell or interruption is based on a half cycle RMS value. That's what the IC specify. A dip is a decrease in the RMS voltage in one or more phases by more than 10% of the nominal voltage for longer than 20 milliseconds. A swell is the opposite of that, so it's an increase by more than 10% above the nominal voltage for longer than 20 milliseconds. An interruption or under voltage is a dip that lasts longer than 3 seconds, depending on the depth. And as I said earlier, the IEC 61000-430 specify that the power quality instrument continuously track the RMS voltage in whole cycle resolution. The VECTO 3 tracks using 1/6 of cycle resolution for the RMS voltage. The VECTO 3 can also be configured to obtain additional information. So by default, the IEC specified that you need to record the RMS values, the half cycle RMS, the depth and the duration of a dip or a swell. The VECTO 3 can also record additional information, pre and post data. So data before the event started and then data after the event stopped. And you can specify the period of data you want to record and what additional data you want to record. For example, you can also record the 50 kilohertz sampled waveform data to analyze during the dip, and also the 200 millisecond harmonic data. Now, these dips and swells are then classified into different sort of events or dip types. The NRS 048 also specifies what is classified as what sort of dips. So you get wide dips are the most regular or often seen dips that you can see on the network. When it's longer than 3 seconds, then it's seen either as an undervoltage or an interruption, depending on the depth. So load shedding events, for example, will be sustained interruptions for longer than for 3 seconds. So it's seen as a sustained, but you also get momentary interruptions as well. And this scatter plot can be provided on Osprey PRO, and our device can, in the reports that I will show you later on, will automatically plot the dips for you on the scatter plot. So you can see here's an example of a site where all the dips or the dips can be seen, the duration and the depth can be seen at that point of measurement. All right, so example of a power quality management solution, CT Lab has a software called Osprey PRO. Some of you may already used it before, or you covered that in the training that was done last month. But Osprey PRO is a cloud-based software. It's permanently online, meaning you can always access it, and you can view data almost in real time. It's accessible from any electronic device with an internet connection and screen, so you can access Osprey PRO using your mobile phone. And Osprey PRO, any Osprey PRO user can do a power quality assessment. So Osprey PRO does the calculation for you and provides you with an automated power quality report, which you can also schedule to be delivered via email. And it's not just the NRS 048 standard that's compatible, but we also have international standards such as the EN 5160 and so on that you can also generate reports for. Now, the automated, something that has recently been added to Osprey Pro is the ability to generate automated quality of supply assessment reports for IPPs or renewable power plants based on unique contractual levels. So IPP will have a contract with utility with contractual levels or apportioned levels that they need to comply to. And you can actually on Osprey Pro specify these values or these limits and then generate an automated report which will compare your power quality assessment to that levels and not just to the NRS 048 compatibility levels. I will show you an example of that as well. So another feature of Osprey Pro is the ability to provide notifications when there's voltage disturbances. Now, these notifications are almost in real time. So you'll get a notifications in a minute or two after the event happened. And that can be pushed to you via email. So you can be notified at any place that there was a dip in the network. And it can also generate voltage incident or event reports that will include, for example, all the basic information that's specified or that's required, such as the duration, the depth of the dip, also the scatter plot, and all of that information. We have a feature that we call incident matching. Now, that feature is very powerful in assisting you to analyze how network disturbances impact your equipment. If you have a network with a fleet of power quality recorders that's installed in different places on the network, what incident matching does, because the devices are GPS time synchronized, it will pick up that an event happened and it was, for example, triggered on multiple devices, and those events will then be grouped into one incident, which you can then analyze. You can then analyze how a dip or a fault in the network was seen on different places in your network and how it propagated and then impacted your equipment. So it's a very powerful feature. You don't need to analyze each event that was recorded per device individually. So it's grouped together into one incident. All right, before I show you just an example of the reports, I just want to conclude then the presentation part, and that is the NRS 048 2015 is the latest version. It's also the minimum technical standard for voltage quality. The voltage supplied to customers need to comply to the minimum voltage quality benchmark by the NRS 048 2015 in South Africa. Customers affect the quality of supply, and that's why power quality management requires measurement of current, and that's also why edition 3 of the IEC 61000-4-30 is important, so that it's also certified to measure current in addition to the voltage. All right, GPS time synchronization is very important to allow comparison of data between different locations geographically far apart. In the next two training sessions, we will look at voltage waveform quality management. So a bit more detail, in-depth detail on how power quality assessment is done, and also an example of a power quality assessment report that was generated on Osprey Pro, and then also how you can manage voltage dips, analyze it, and how it's basically the info is provided on Osprey Pro. Okay, so I'm going to stop the presentation, and maybe before we go on to a demonstration, do we have any questions on this presentation? Okay, I don't see any hands. Let me just see if there's anything in the chat. All right, I don't see anything. If you have any questions or can think of anything at a later point, you are more than welcome to send us an email, and we'll get back to that. So I'm just going to stop the presentation and then also share my screen. Danielle, can you confirm if you can see it?
Danielle's dropped out due to load shedding, ironically. Yes, we can see. Thanks.
Thanks, Randolph. Okay, we don't want to see that. We actually want to see the demonstration. Okay, so for those of you that's not familiar with Osprey Pro, as I said, it's cloud-based. You can access it from any web browser on any electronic device. So I'm currently logged into my user, and I'm specifically looking at our demo account. So if you need more information on Osprey Pro, what it can do, all the functionality, the concepts, and we have, I think, 2 or 3 previous presentations and webinars that was focused on using Osprey Pro. So please, if you want that, we can also share the link, or we will actually share the link to the YouTube video that's posted on YouTube. And if you have time, you can go through that as well. So just to show you an example of how power quality assessment reports look on Osprey Pro, and also how easy it is to generate a report. We have 4 meter points that was set up. We have all 4 of them listed here. And we can now generate reports for each one of them. So if I go to Home Reports, there's 2 different ways of reporting. We have ad hoc reports, which generates reports on the fly, but you can also schedule reports that was mentioned in a presentation to be sent to you via email at any date. So you can actually schedule a report for power quality assessment to be sent to you automatically monthly at a certain time or date, or even weekly. So it does all the heavy lifting for you. Basically, just to show you an example of a report, I've created 2 different reports. The first report is a power quality assessment report. Let me just scroll up. So we call it a site assessment report that was based on the NRS 048-2/2015 for the period of 1 January to 1 February for the beginning of 2022. Okay, you can see what the declared voltage is. We can see the voltage availability or the data availability. We can see that 99.6% of the data is available, and only 0.4% of the data in this month period was flagged. And that's because obviously due to dips. So that 0.4% is events, dips, or interruptions that flag the data, and that 0.4% is removed from this assessment. Okay, now the assessment will look at firstly the voltage magnitude or voltage regulation. So it will provide you with the assessed values, the minimum and maximum assessed values, and that needs to be within 95 and 105% of the declared. So the 95th percentile value, the highest and lowest value, needs to be between 105 and 95% of the declared. And what you can see for this specific site, it's very stable. The voltage basically runs at 100% permanently. So this is just the 7-day sliding assessment. Now we also plot the actual 10-minute trends, which you can see in this graph, and then a histogram to give you more information on how what's the band within where the voltage runs. So you can see it's basically from, what's that, almost 99% to 101%. So it's within plus minus 1% of the declared is how the voltage is running. So it's very stable and consistent. Going on, then there's voltage unbalance, which will compare your 95th percentile voltage unbalance value in that week, which was assessed at 0.3, and compare that to the compliance level of 2%. So you can see that the unbalance is also very low at this site. The same for flicker. Flicker is a bit higher, 0.7, but it's still within the 1 per unit limit. THD 2.2%, also far below the 8% limit. You can see how the THD changed over this period, and also then the current THD as direct comparison with the voltage THD. You can get a typical profile of how your THD looks over a week period. So it gives you some idea of how the THD is impacted by the load. Then the events during this month, so you can see there were 6 dip type Ys, 3 dip X1s, 2 dip X2s, 1 Z1 dip, and you can see them on the scatter plot, what hour of the day and what day of the week the events happened. Comparing, you also see here's a declared voltage, so your voltage, your RMS voltage, and then the dots illustrate or where in this month period there was a dip recorded. So you can see here, for example, was 3 events basically on the same time. So it's probably one incident that happened multiple times.
Sorry, Hein, just on that graph, if you scroll up a bit, important for the attendees to note that the y-axis on the right-hand side indicates the residual voltage. So the height of your dot vertically tells you how deep the dip was.
Yes, 100%. Thank you, Randall, for that. And then we also have the table that shows you what date specifically, what time, duration, what the residual voltage is. And then we have built in to the Vector 3 algorithm that basically implements 3 different papers, research papers, on accurately determining if the event is upstream, or event happened upstream or downstream. And the interesting thing that you'll see here is that all the events that was recorded as at this measurement point during this period is all indicating that it's upstream related. Now, obviously, you'll need to do some more research or an investigation on your own just to confirm this, but this already gives you a good indication of where the events propagated from. Okay, and then your individual harmonics will also have, voltage harmonics will also have limits that's specified in the NRS for different voltage levels, and the assessment power quality report will automatically compare the assessed value for each individual harmonic to what that limit is, or that compatibility limit is for each individual harmonic. And then you can see that there's no real issues here. It's well below the limits, so no issues in terms of that. And then we have also a consumption report. This is just, it's not part of the power quality assessment necessarily, but it will show you what your maximum demand is, what is the reactive power, your power factor during this period, and so on. And then you'll also just have more data on analyzing each individual harmonic. So if you see there's an issue with a specific individual harmonic, you can analyze that in more detail using the harmonic contextual trends that's also shown on this report. Now, the difference between this power quality assessment report and the second one is that the second report is actually a site assessment report that's based on the contractual level. So what I've done here is I've actually set up this measurement point with certain apportioned levels. So levels that you can, for example, the contractual levels that IPPs have. So they will have their own voltage unbalance, flicker limits, or THD, and then limits for the individual voltage, or in most cases, current harmonics that they need to compare to. And you can specify that for each site, and then generate a site assessment report that will not just compare your assessment with the normal compatibility levels, but actually against the contractual levels. For example, here you can see I changed the limit to 0.2% for voltage unbalance, and now it's not complying. So the assessed value is actually 0.3, and you can see it basically runs above that most of the time. And so you can do it for each individual parameter that you can set up. Same for flicker, THD, and then more also very important, then your current or your voltage harmonics. So here it will not just show you your voltage harmonics compared to the limits, but also actually your current harmonics, which is very important for the IPPs to show compliance that they do not exceed the current harmonic limits. So I think this adds a lot of value to quality of supply engineers that needs to do assessments on grid code compliance for renewable power plants or IPPs. All right, I think for today's session, that covers most that I want to show as a live demonstration. In the next session, I will focus a bit more on the actual power quality assessment. What does voltage unbalance mean? How is it assessed? What impact does voltage unbalance have, and what can cause bad unbalance? And we'll go into more detail on all of that, and the same for dips as well. How to analyze dips and how to view, annotate dips, and just a few examples of how you can do that as well. Okay. Do we have any questions at this point?
And before we dive into the questions on the chat, and I also want to encourage people to raise their hands if they're not keen on typing a long question. It's important to note that our platform is already ready for more than just NRS 048 and IEC 61000. If you are considering doing projects abroad, we are already compliant with the EN standard as well as the IEEE 519 standard. In a lot of countries that don't have country-specific power quality standards, they usually refer to these two. I see the New Zealand standard is also on the list, and that was a new specification there.
Yes, 100%. So to show that as an example, you can actually, I need to share my screen again. Sorry for that. If you generate a report, a site assessment report, you can select the classification standard. So here we have the latest NRS, EN 5160, IEC 61000 standards. Now, I'm not familiar with all of them specifically, but the nice thing is that Osprey Pro has this built in, and you can, as an Osprey Pro user, no matter where you are in the world, generate an assessment report that is relevant to that area, to that regulation. You specify the period and then also the measurement point. And another thing that I forgot to mention is that these reports are not just generated in PDF form, but also actually in Word format. So all of these graphs and tables are, specifically the graphs, are in vector graphics format. So the quality is very high, and you can directly just copy and paste that into one of your individual reports for further analysis. So that makes basically generating a custom report a lot easier than you would normally. So I think that also adds a lot of value. Ranoff, anything you want to add to that?
Yes, Hein, just on the top drop-down list of the report type, perhaps if you just hover over that so they can see, we report on a lot more than just PQ standard. So, I mean, key performance indicators, facility losses, it really is a comprehensive suite of reports that can be auto-generated. I'm going to go out on a limb and say that most of the attendees have spent more time than they wanted to generating reports manually and then building them in Word, etc. So you can really take the brunt of your heavy lifting out by auto-generating a report, and then in Word only taking snips into your specific report format that you would require as well.
Yes. Yeah, thank you for that, Randolph. So yeah, and the great thing is that these reports can be scheduled. So you can receive them automatically in your email whenever you want to receive them. So that's quite a handy feature and very powerful as well. Okay, let's get to a few questions. I think I saw a question from Brandon Peterson. How do you deal with the direction of harmonic emission in our assessment, specifically for IPPs? Yeah, I think that's a very relevant question, Brandon, and it's not something that is per se handled in our reports or something that we do handle at all. I think that is something that requires a bit more of your own investigation and the methods that you use for that. As you would know as well, with your research, I know with prevailing phasers, we can provide you with all the information that you can use to do your analysis on what the direction of harmonic emission is. So I think it's a good place to mention that one specific area that Brandon Peterson that you've done specifically research on is the prevailing phasers and how that can be used to determine if an IPP is generating or absorbing harmonic current. And Osprey PRO, and not just Osprey PRO, but the VECTO 3 actually also records and saves that value for you. So although we do not per se have it automated in a report, we do have all the information that I think that you can use or mostly use to do your own investigation on what the direction is. But if you have any maybe any ideas of what we can do, I think we always like to say that we are a company that provides features and functions to customers. We want to build tools, we want to build software that can help you do your analysis and make your work easier. So if you have any recommendations, Brandon, I see your hands up, so you're welcome to add.
Thanks, Hein. The concern I just have with your automated reports, and it's specifically coming to the IPPs and even these renewables and things that are coming on board, is that the requirements for compliance is actually quite specific. And I'm just a bit worried that someone might actually submit some of these reports to a network service provider and say, but here's my assessment report, and I am compliant or I'm non-compliant and those type of things as well, which is why I'm asking the question in terms of the harmonic direction. The other reports and things, that's fine, but when it comes to the IPPs, the requirements are actually quite specific as well also. And as you know from your past, the fights we always have with IPPs in terms of who's actually causing the problems. That's one of the criteria that's on here as well. I admit it's a useful tool, but I'm just saying, just be careful when you're saying, yes, you can generate the reports, and then someone submits it to an NSP, and then we outright reject it because it's not what we're actually looking for when it comes to the compliance assessments. Thanks, Hein.
Yeah, thanks, Brandon, and I 100% agree with that. Randolph, do you have a comment?
Yeah, sorry, Brandon. Thank you for your insight, specifically from the ESCOM perspective of things. It goes further to a point that Hein mentioned in his presentation, that it's the responsibility of both the customer and the utility. So I believe that if a report is set up correctly to the site-specific contractually agreed thresholds for compliance, that a report that's I want to say tweaked and custom set to the specific contractual requirements could be sent to a network service planner. It'll obviously lead to a further conversation, but Brandon, I'd like to hear your opinion on this.
No, fair enough, but that's what I'm just saying, right? This is now, if you don't take in the direction of the harmonic, because what I'm assuming you're doing is you're taking the measurement over a certain period, and then you actually go and calculate the 95th percentile compared to the actual emission components that's given in the actual contract itself. but it's a bit more than that, you know, because that's what the guys normally do. But now the question starts coming in is when there are violations, what do you actually do? Because this is where the fight starts coming in, or the debates, let's put it that way, where about the NSP are saying, but we're not the problem. Then the IPPs are saying, but we're not the problem either. So this is what I'm saying, right? This is somewhere, somehow, you do need to bring in the direction into this whole thing, because that is part of the grid code requirements. It's something that's going to come up more and more, especially with this 100 megawatts and things that is actually being connected all over. So network service providers, and when I'm saying network service provider, it's basically anyone that will allow an IPP to connect in their network. All right, so it's not just Eskom, it's municipalities, everybody that will be involved in this. And also when it comes to the whole wheeling things, etc., it's going to be a bit more complex. But what I'm just cautioning you on is saying that, you know, yeah, you can send this report to your NSP, and you know they will be able to, you can use this for the compliance and things on it. I'm just saying, you know, just take it with a pinch of
Brandon,
salt.
I think we're saying the same thing. Is essentially our report is not a bot-generated answer to everything. It should still be read with the knowledge of a power quality expert and then interpreted to be taken into a discussion with Eskom and other NSPs. But on that note, Hein, is it possible for you to pull up on your side from Osprey Pro the graph that shows the harmonic spectrum, but specifically whether it's sourced or sunk? That's what I'm assuming Brandon's alluding to, the directionality of the harmonic emission. Is it possible for you to show that graph?
Randolph, I think what Brandon is referring to is not per se. I think you're speaking about the direction of the dip, which is upstream or downstream.
No, I'm sorry. I'm talking about the graph that shows the power component of the harmonic above or below the line, whether it is sourced or sunk. It's not the up-down directionality. Let me see if I can find one on my side.
You do know that the grid code actually does not recognize that method as an acceptable assessment, huh?
Yeah, that's what I just wanted to add. Is there's certain methods in place, Randolph, that for example, the impedance slope plot is one method that's very detailed in standard, and as I said earlier, the prevailing phasors, that's a new method. I'm not sure, Brandon, I think from my understanding, if a client can prove with ways that the method they're using is actually logical and engineering correct, then they can actually use any method. Is that not correct? But
No.
But to add to that, I think that we can expand on the report. This is a good place to start for someone to do the foundation work of a assessment report for IPP, to just get an understanding of what the emission values is. But you still need to do your own investigation on then the direction. But there is maybe some more expansion that can be done specifically on using tools such as the prevailing phasors, and see if we can add that as an automated way that can show and prove if it's sourced or absorbed. I'm not sure if that sounds correct, Brandon, or you can agree with that.
Yeah, no, the thing is, right, is you're going to have to do a bit more work on it, because there's quite a number of methods in it, but it is specified in the actual reports itself, in the grid code document, in terms of what methods we will allow and which methods we cannot. It comes down to the whole thing about fairness and making sure that we treat everybody exactly the same. But the point I just want to make, and I agree with you, Highness, is yes, it is a good point to actually start and to see, but where are your, your issues, if there are any. I'm just cautioning to say that, guys, be careful. Randolph, you've also said it yourself, that you still need to interpret this, because I have seen it in some cases where the guys take an automated report and they want to send that through as an assessment on it. And that's what I'm just saying, right? This is just be careful of that. You've said the right words when you're coming there to saying, okay, you need an interpretation from a power quality engineer that actually will give you the right assessments and the wording and analysis to go with it. I'm just mindful that, not everybody is skilled in these environments, and, it's easy to click the button and to get a report out of it. And I'm just saying, just be aware that if they do give it for compliance, some utilities might not be happy with it.
Brandon, just on the topic of power quality standard compliance, I don't know, perhaps even Hein could answer this question. If a customer installs one of our devices and finds that the quality of supply is outside measures, how is the process to engage with Eskom on such a, let's say, exceedance?
Look, the first point of call is to actually engage with your customer services representative. They will then internally lodge the complaint or the query through to the relevant department that actually deals with it. You must understand that, and I'm purely speaking just from an Eskom background, municipalities in their own right will maybe have different processes that they actually deal with it. But should an exceedance be picked up, what will then happen is that, like I said, through the customer services representative, they will then engage with the different departments. Each and every region, or what do they call them now, clusters, have got different representatives that can actually deal with the complaint from there onwards. But try and be as specific as possible, dates and times, when did the exceedance occur, because then it makes it easy for us to go back and try and correlate it with a certain network event, if such a thing is if it's a once-off event, or if it is something that's sustained, then obviously we will have to take further investigation to try and understand where the problem is coming from. But your first point of call is your customer executive.
Thanks, Brandon.
Thank you, Brandon. Appreciate that. Graham, sorry, I see you were speaking up.
Sorry, slip of the mic.
Okay, is there anything you want to add, or just an accident?
It's literally just a fat finger on the mic button.
Okay, thank you for that. Brandon, I appreciate your your feedback and your information that you provided. I think it's something that we can internally discuss as well. I think this is a good starting point, and it's something that, as I said, it was recently added, that I think that can be expanded on. But all the points that you make is definitely 100% valid. Do we have any more questions specifically on the training?
Can I be a critic?
Yeah, you're welcome. Yes.
All right. I would suggest you actually spend a bit more time on your that chart that between the compatibility levels and the equipment emission level or equipment sensitivity levels as well. Also, the chart that comes out in NRS 048, where you're basically showing the utilities how can I say, utility performance levels versus equipment performance levels, because that is effectively the crux of power quality management on it. So if you're going to go this forward and you're going to present a bit more data or more insight onto it, spend a bit more time on that, because that is effectively what power quality management is all about. It's easy for everybody, but this is what it's about, and this is where the compatibility levels come from, etc., etc. But to understand how those things are actually built up and what the different probability density curves mean, it's actually quite interesting, because that is effectively where the NRS standard comes from. So just in terms of going forward on it, spend a bit more time to unpack that, because then you can start getting the understanding of everybody around the table as to, but hang on, it's not just the utility that must do something about the power quality management. You've also got the load side in terms of the different equipment that has also got an aspect that they need to look at. So just to make sure that you get that balance. Thanks, guys.
Thanks, Brandon. Appreciate that. We'll definitely focus a bit more on that and add more expansion on that as well.
Yeah, and I think if we, with this recording, just guide the attendees also to the previous recordings, it'll add a lot of value for them to see this specific training in context with the other trainings.
Yeah, so obviously we've just, some of you, I think it's the first time if you've joined a training session, and I thank you for joining this. We tried doing this a monthly thing, so going forward, we definitely building on training programs. So as Brandon said, we appreciate all feedback that can be added. We're trying to learn everyone in this field. It's a complex power quality field, and I think it's a very key and important area that needs to be focused on going forward with the energy crisis, with the renewables coming online, and it's going to become more relevant even going forward. So yeah, we want to try and add value as far as we can from CT Lab's point of view, and we appreciate all feedback that we can get. So thank you very much for your attendance. If there's no other questions, then from my side, I think we are done. Do anyone want to add anything?
Okay, Han, before we go, before you go on the admin side, on the register, I've got a few candidates or attendees that I don't have their email addresses. Can I just mention their names and then they just comment with their email addresses and the name of the company, please, for me? I've got Albert Couperas. I'm not sure if I'm pronouncing it correctly. Andrew Grant, Brandon Peterson, Kos Mkanzi, Jannes Jansen, Van Vuren, Loris Julius, Malcolm White, Mandri van der Metz, Patrick Matthews, just a second, the last one is Velem Pretorius. Can I please have your email addresses and the name of the company, please? Thank you, Hein. Over to you.
Okay, thank you very much, everyone. Appreciate you joining, and our next session will be next month. I think the date, if I don't have it, let me just quickly check my calendar. It should be the first week of August, the first Tuesday, which should be either I think the 2nd of August, but we'll confirm that with the email. So you are welcome to send a link to the next meeting to your colleagues or to anyone that you know that may be interested. From my side, I thank you very much. I appreciate you joining, and I hope you learned something. You're more than welcome to contact us if you have any further questions. Enjoy the rest of your day. Thank you.
Thank you.
Thank you, Hein. Thank you, guys.
Thanks all.
Thank you very much,
Have a nice
Hein.
day.
Thank
Bye-bye,
you.
everybody.
Thank you.
Thanks all. Bye-bye.
Thanks, Hein. Bye.
Thank you.
Thank you.
Bye, everyone.